Hi folks, this is Satish Kumar and today we are going to discuss about matrix addition. So how are you going to do matrix addition? So first we will be checking the logic, and next how do we implement this matrix addition in the C programming. And then we will look about the program also, coding of your matrix addition. So let it be the A matrix, where it is, what is the order of this A matrix? It is 2 by 2 matrix. And this is a B matrix, which is of order again 2 by 2 matrix. Whenever you're going to add A and B, then you get a resultant matrix C as what? 1 plus 5, 2 plus 6, 3 plus 7, 4 plus 8. This is what we learned in mathematics, how to add two matrices. Right now what we have to do is we have to write a code in C programming such a way that it also adds two matrix and gives us the resultant matrix. How do we represent matrix in C? So we have a data type called arrays, where we use this array as the matrix, right? First of all, before that, what we have to discuss is what is an array. Array is a collection of elements of similar data type, right? Example, A of 5. 5 tells you about how many elements are there in that array. So 1 2 3 4 5. So this array starts from index 0 and ends with this size minus 1, that is 5 minus 1 is 4. So 0, 0th index, first index, second index, third index, fourth index. In the same way, what is two-dimensional array? Two-dimensional array is a representation of rows and columns. It is also called as array of arrays. Can you see this? Say, have we represented the same thing in the curly braces or braces? In this same, we can see again an array structure, right? So that's the reason why we say it as array of arrays. You can see it 1 comma 2 and 3 comma 4. It is because it is a 2 by 2 matrix, so 2 elements in one array, 2 elements in another array, so 2 by 2. So we can say that it is a array of arrays. So you will represent in this way. If you closely look at this, is it looking like a matrix? Yes. So that's the reason why to represent a matrix in C programming we use two-dimensional array. Now how do you add? So we'll be adding as 1 and A1 B5, that is first rows first column and first rows first column of B. In the same way, first row second column of A and first row of second column B. In the same way, second rows first column of A and second rows first column of B. In the same way, second rows second column of A, second rows second column of B. So we will add like this. So this is how we will be adding the matrix. Right now we have to represent it as a two-dimensional array. As we are representing a two-dimensional array, in an array index starts from where? It starts from 0. So that's why 0th row 0 column plus 0th row 0th columns. Can you see here 0 0 0 0? So this red colored 0 0 is for the first matrix and blue color 0 0 is for the second matrix. And now we want to add this particular thing. So it is what? It is 0th row first column and 0th row first column. Can you see over here? So 0 1 0 1. So what we need? We need data, and data which is stored in the index, that also we need. So these are very important. We need data, that is 1, and 1 stored in the index. Which index? 0 0. Whose 0 0 it is? A 0 0. And if it is 5, whose this 5 is stored in what? 0 0. Whose 0 0 it is? B's 0 0. So I think you understood, right? So this is the algorithm for the matrix addition. So first step is start, and next second step we have to read two matrices, that is A2 by 2 and B2 by 2 matrices. In step 3 you are incrementing you are initializing I is equal to 0. So I and J here represents rows and columns, because we said, right, we are going to use for matrix 2 by 2 we are going to use 2 by 2 array, right? For a matrix we are going to use two-dimensional array. So in a two-dimensional array, index starts from what? 0. So that's the reason why I am going to take I is equal to 0. And in step 4, I less than 2, that is we are checking whether I is less than 2. Why this we are saying I less than 2? Because index should be less than, index should be equal to what? Size minus 1. So that's the reason why we took I less than 2. Then continue. So now in the step 5 what we are doing is we are initializing J is equal to 0. In the step 6 we are checking whether J is less than 2 or not. So that is 0 less than 2, then continue. So if you are going to continue, then now you will get step 7 as Cij is equal to A of ij plus B of ij. What is I and j here? 0 0. So now whenever I'm going to tell about this thing, what you have to do is you have to take a pen and paper and write the values of I and j so that you will understand properly. So C is what? C of 0 0 is equal to what? A of 0 0 plus B of 0 0, because I is 0 and j is also 0. So what is A of 0 0 and B of 0 0? So this is A of 0 0 is what? 1 plus B of 0 0 is what? 5. So now you got the first element, that is first element of what? C. So C of 0 0 you got. Next step is what? You have to increment j is equal to j by 1. So that is j is equal to j plus 1. Now j is 0 before. Now it becomes what? 1. So once it is incremented, go to step 6. In step 6 it is checking what? J less than 2. That is 1 less than 2. True or false? True. So if it is true, you have to continue. So continue is what? C of, have incremented I? No. It was what is the value of I now? 0. So C of 0 1 we are calculating. So C of 0 1 is equal to what? A of 0 1 plus B of 0 1. So what is A of 0 1 and B of 0 1? 0 of 1 is 2 and 0 1 of B is 6. So 2 plus 6 is 8. So it is value in what? Value in C. So C of 0 1 you got now, right? And next in step 8, what you have to do is, step 8 is j is equal to j plus 1. That becomes what? 2. So you have to go to step 6. So in step 6, j less than 2. So your j became what? 2. 2 less than 2 is false, or is it true or false? False. So as it is false, you have to increment I is equal to I plus 1. That is 1 plus 0 plus 1. So now I becomes 1 and go to step 4. Now check value of I. 1 less than 2. True or false? True. So if it is true, you have to continue. Now again j became what? In step 5, j became again 0. So I is 1, j is 0. So now you are checking here, 0 less than 2. True or false? True. So here C of ij, that is what? C of 1 0 is equal to A of ij plus B of ij, that is A of 1 0 plus B of 1 0. So A of 1 0 and B of 1 0 will check. So A of 1 0 and B of 1 0 became what? 3 plus 7 and it is 10. So C of 1 0 became what? 10. So we got this value also. Next what you have to do is j is equal to j plus 1. So j became 0 now. So it becomes 1 now. 1 plus 0 plus 1 is what? J was 0. So now j is equal to 0 plus 1, that is 1. So you have to go to step 6. 1 plus 2 is what? 1 is less than 2 is what? True. So C of I was what? 1. So I of 1 1 is equal, sorry, C of 1 1 is equal to A of 1 1 plus B of 1 1. That is, we have to check that what is this. So A of 1 1 and B of 1 1 became what? 4 plus 8 is equal to 2. So overall answer given to what? C of 1 1. So it is same thing. So next step 8, j is equal to j plus 1. J is equal to j plus 1 is 1 plus 1 2. Go to step 6. 2 less, in step 6, 2 less than 2. False or not? False. As it is false, you have to move to I is equal to I plus 1. Already I is 1. So 1 plus 1 is what? 2. So you have to go to step 4. So now if I less than 2, now I became what? 2. 2 less than 2 is what? False. If it is false, you have to go to step 9. So in step 9, you have to display C matrix. So while we discussed, we got this value also, and 1 0 value also, 1 1 value also. So we got 0 C value. So it prints C. C is the addition of two matrices. This is the algorithm for the matrix addition. Now suppose if they don't give the order of the matrix, if user is only interested to give the order of the matrix, then how to write the code? Suppose if they do not give you the order of the matrix and user himself has to give the order, that is at the time of runtime, then how do we write? Because whenever you compile this, always it takes only 2 by 2 matrix only, right? Because we have mentioned it as 2 and 2. So instead of that, if user wants to give the matrix order, then how do we write the program? We'll just check that. So this is what the algorithm for the addition of two matrices where order is also given by the user. So first what we do is, we'll start it and we'll read the AR, AC and BR, BC. What is AR and AC? It is A matrix row and A matrix column, B matrix row and B matrix column. If A matrix row and B matrix row are same, and also A matrix column and B matrix column are same, then only you continue, else don't. It's not useful, right? Because both matrix should be of same order, then only we are going to add it. So in the step 4, you'll be going to read, if it is true, then only you are going to read matrix A and matrix B. And this is same, right? Where from step 5, step 6, step 7, step 8, step 9, step 10, step 11, these are all same, whichever we already written this, right? In the previous thing you have written, right? Only the thing is this one, whether it is true only, then you enter into the thing, else you don't know. Else for example it is not true, then what you'll do, you'll go to the step 12, where step 12 will say that both rows and columns of two matrices must be same, and you'll stop. Right, this is what the algorithm for the two matrices where order is also given by the user at the time of runtime. Right, how do you input the values for a two-dimensional array, and how do you display it as a matrix? We'll see the program. Right, this is what, how do you input the values to your matrix. You will ask enter the matrix elements. So I is equal to 0, I less than IR, I plus plus, this is for the rows. J is equal to 0, J less than AC, J plus plus, this is for the column. And you will ask the user to enter, give the values. So scanf %d ampersand A of ij. Okay, so it repeats. First it does what? First it takes 0, and this is 0, 0, 0, 0, 1, 0, 2, 0, 3, so on like that. And if it is false, then it comes here, I will be incremented by y, again by 1, again it will be 1, 0, 1, 2, 1, 3, so on like that. Again if it is false, again it goes back there and it becomes 2, so 2, 0, 2, 1, 2, 3. So you are getting the matrix formula. Right, in the same way, how do you display? So you will be displaying like this. For I is equal to 0, I less than AR, I plus plus. Instead of scanf, you will be having printf. So printf %d A of ij. And why do you write this particular thing is, once a particular row is completed, you need to go to the next row, right? So for that reason, once it is false, it will add the one line, and then it moves to the next row. So in this way, this is there for the displaying the matrix. Now what we do is, we will be seeing the program of matrix addition. So this is for the matrix addition program, where we have gone to the second way of program, where second algorithm, where rows and columns are also asked by the user to give at the runtime. So I took A of 10, 10, where it can store maximum of 10 rows and 10 columns. 10 rows and 10 columns in B also, 10 rows and 10 columns of C also. Now its user wish, he can give till 10, right, because it is 10, 10. So AR, BR, AC, BC, you know, right, array of A matrix row, B matrix row, A matrix column, B matrix column. So now first we have to ask the user to enter the first matrix row and column. So that's why you have written ampersand AR, ampersand AC. In the same way, you need to ask enter second matrix row and column, that is BR and BC. If both are same, then only you have to enter into it. Once you enter into it, first you need to tell the user to enter the values for first matrix, that is ampersand Aij. In the same way, you are asked the user to enter the second matrix element. As it is a two-dimensional array, you need to have two for loops, right? This I is for row and J is for column. So in the same way, you got ampersand Bj. And as now you got first matrix element and second matrix element, you need to add. So for the addition, you got the logic as this one. This is the logic for the addition. For I is equal to 0, I less than AR, I plus plus. For J is equal to 0, J less than AR, J plus plus. So C of Ij is equal to A of Ij plus B of Ij. So the logic is completed. Then you need to, what you have to do, you have to print this particular matrix. So you are going to print this as I is equal to 0, I is less than AR, I plus plus, J is equal to 0, J less than, right? So this is what, how do you print this? Okay, so for example, if it is false, then what you have to do, both matrix rows and columns must be same. This you are going to write. So shall we see the output? Yeah, compile. So it is compiled successfully. Then shall we execute this? Yeah. So now enter first matrix row and column. So I am entering it as 2 by 2. Okay, enter second matrix rows and column. This also I am giving 2 by 2. Okay, enter first matrix element. So 1, 2, 3, 4. Okay, enter second matrix elements. So I am giving it as 5, 6, 7, 8. As this is way to carry example, you will understand easily, right? Output. So output is what? Matrix is 6, 8, 10, 12, which we got, right? So this 6, 8, actually we didn't give this as a matrix way, right? But output we took as a matrix way, because I said printf slash n, right? So this is what, how. So we'll take another example, another output also, where I'll give different rows and columns. So for the first matrix it is 2, 2, and for the second matrix it is 3, 2. So what is this? Both matrix rows and column must be same. So have you executed anything? Nothing, right? Directly we said the else part, saying that both matrix and columns must be same. Please subscribe to my channel for more videos. Thank you.